Good morning. My name's John Jarvis. I'm a technical consultant on the solutions team here at Somerford Associates. I'm a Splunk architect and a certified HashiCorp professional in both Vault and Terraform. We're here today to talk about the former Vault and how it integrates with Splunk. So without further ado, what are we going to cover on the agenda today? Okay. We'll start with a brief introduction to Vault itself, which applies to the open source software offering as well, by the way. Then we'll look at the enterprise grade offering, which you'll need in order to get a copy of the Splunk app. That's the highlight of today. And I should say, please interrupt at any point if you have questions. Throw them in the chat. I'll check the raise hand function as well. I'll try to keep an eye out for that. Let's just keep this informal. So from there, I'll briefly talk about Splunk. It's tricky to pin down, but for those who think it's just a SIEM, a security information and event management system, or just a log aggregator, well, you ain't seen nothing yet, as the saying goes. At that point, we're ready to look at what today is really about, getting data from Vault to Splunk in a manner that allows visibility across your estate, whatever the scale. I'll quickly run through the architecture behind what you'll see today. It's all based on open documentation. I'll provide the links. Then we'll have a look at the app live. I'll attempt to defy the fates. Then we'll finish with a bit about who we are here at Somerford. I'll attempt to answer any questions if you still have them. Haven't posed them at that point. Again, just interrupt me if that isn't clear. Okay, so for those who haven't heard about it, what is Vault? So Somerford do a lot of Splunk webinars, but yeah, for those who aren't that familiar with Vault, we're talking about secrets management first of all. But what exactly does that mean? Well, some of you might be focusing on, say, passwords in a human-sided transaction. And yes, Vault can simply be a key value store for that sort of information, or stepping up in complexity, allowing administrators to manage credentials on an ad hoc basis. But where Vault really shines is in the dynamic space as an identity broker between applications and as part of automated processes. So you have your identity provider of choice, be it Active Directory or maybe Okta, or in the case of cloud-based infrastructure, maybe it's AWS IAM. Vault receives a client request, and once confirming that, yes, AD says this is, for example, Alex from org A. It returns or even dynamically generates and returns access for that particular database on-prem or that S3 bucket on AWS. Alex, or say application B, is an entity to Vault. And through this abstraction, Vault collapses all of these authentication workflows, wrangles this secret sprawl, and is the single source for the associated access policies. And we're just talking about the authentication workflow here. Of course, Vault gets out of the way of the actual work to be done, ready when the tunable time to live is expired on any associated tokens to renew or generate access as the use case requires. And again, some of you probably are aware of this. Terraform in particular is extremely popular, but all the HashiCorp products have a loyal following in the open source community. Just gonna grab some more coffee. Lots of talking today. Okay. So let's get under the hood a bit more. First, I should point out that the slide isn't exhaustive. There's a lot on there, but it isn't exhaustive. For example, the Transform secret engine that's available in Vault Enterprise for doing things like format preserving encryption, that isn't listed on here. It's fairly new secrets engine, but you get the idea. This will give you the idea of the breadth of Vault's interoperability. So on the right, we're talking about all the different ways Vault can work with your applications through, say, its Kubernetes auth method or a generic app role method that you customize. And it does so while also facilitating that identity brokering, that one-stop shop we were talking about for, say, Alex, who previously had, GCP creds, web tokens for an in-house application, LDAP for corporate HR applications, etc., which are all now associated with one entity in Vault as aliases. And if Alex leaves the organization, well, from Vault's perspective, the IDP knows all. So once Alex is removed from, say, the LDAP or whatever, has been configured to be the source of truth for identity in your org, that entity and all its aliases are no longer accessible. Vault will pull the IDP, get a negative response for it being a valid identity, and that's all she wrote. So that's auth methods. Switching to the left-hand side, if we think about tokens that are issued following a successful transaction with one of those auth methods, they'll have policies associated with them, which will determine what that entity is allowed to do in Vault and by extension in the Vault controlled space beyond. For example, take the database secrets engine. So prior to Vault, think about PAM, privileged access management, and humans issued database credentials, humans issuing database credentials to humans, for some task for a limited amount of time. With Vault, we can group database administrators and database users, all managed by our IDP, and then generate appropriate credentials for them, so with the right permissions, right at the time of request, and they can be short-lived, incredibly short-lived, depending on the task at hand. If we combine this with something like HashiCorp's boundary product, just to as a quick aside, human application on the other end may not even see those credentials, which is actually pretty cool. But in the typical scenario we're talking about here, even if the user stores those credentials locally on their laptop and it's stolen, for example, the short TTL, to say nothing of the secret's uniqueness, given that we just generated it, that'll minimize the blast radius, is the idea. And these same principles can apply if we're working with SSH keys or cloud credentials, as you see there on the left. It could be the AWS secrets engine, for example, being used to create API keys on the spot. That's a Terraform cloud within use to build a set of VPCs in your AWS test environment. That's just another example. So the key here, I guess, on this busy slide, is the dynamic nature of those credentials, the limited window of their validity, and the automation that surrounds all of this. So hopefully that's clear. Okie dokie. Moving on. Everything that we've mentioned so far is available in the open source version of Vault. And while some of the options open to you regarding monitoring your Vault open source software nodes, access to the Splunk app we'll be looking at today is limited to Vault Enterprise customers. Similarly, what follows here are a few highlights of Vault Enterprise. You'll notice a common theme of scale. That is, much of what comes in when you're talking about expanding your deployment beyond a single cluster, or that cluster is overtaxed, basically. That's when Vault you should be thinking about Vault Enterprise. Or actually, maybe your company's acquired another company that's using Vault. You probably want to look at namespaces in that instance. Really, any scenario where you see that sees your Vault administrators getting overwhelmed with requests is when you ought to be thinking about it. In a nutshell, it allows you to delegate certain responsibilities to other Vault teams while retaining broader control and governance over the whole organization's use of Vault. So it's like vaults within vaults, where an administrator of a child namespace can manage their paths and their TTLs as they see fit, but they can only use particular secrets engines and auth methods that have been approved by your security team, for example. And likely before namespaces even hit your radar, you'll be thinking about business continuity planning. Vault open source software, OSS, doesn't provide any means of securely switching to a warm standby, for example. or even backing up your clusters in any sort of automated fashion. High availability, or HA, which is part of OSS, open source software, that refers to servicing requests. That is, if the primary node in your cluster fails, another will be elected to take its place. However, it's still a one-stop shop for requests. And as your deployment grows, your performance will degrade. That primary node or the secondary that takes over, it can only service so many requests. This is where performance replicas come in. While writes will always go back to your primary cluster, you can set up secondary clusters to service much more common read requests locally. Hence, they're being called read replicas as well, as you'll see there on the slide. That takes the burden off the primary cluster. And you may not want all your data replicated in such a manner. That's where mount filters, and in the case of namespaces, path filters come in handy. Say you have a cluster in North America and another in Europe. You can set up filters such that certain customer data remains local to the cluster, while the rest is replicated to comply with regulatory requirements, for example. I won't go over all these in the interest of time, but multi-factor authentication and hardware security module, auto unseal will probably be of interest to some of you, and you can check out vaultproject.io for more information. Sentinel is worth a moment, however. It's HashiCorp's policy as code solution, sitting across all the HashiStack products. Briefly talked about organizational governance with namespaces. And it's Sentinel that will provide the guardrails to go along with that. With it, you can set up warnings or soft mandatory rules that can be overridden by an administrator or senior staff, and hard mandatory rules that everyone in the organization must comply with. And again, that's all automated. Okay. So let's switch gears a bit and look at Splunk itself. Some of you may think of Splunk, as I said, as a SIEM, security information and event management tool. And it certainly does that with something like the enterprise security application, but it's a platform. Splunk's a platform that will work with any data. So ITSI, Splunk's IT service intelligence application, it presents a glass table and give you immediate insights into your business processes more generally, allowing you to drill down and perform root cause analysis on all sorts of inefficiencies that have absolutely nothing to do with security. So it's really a much broader application. In a nutshell, basically, if you're generating data and attempting to identify patterns in it or building processes around it, Splunk is the answer. And this is no different when we're talking about, like we are today, the operational logging and metrics associated with your Vault cluster. So let's dig into that now a little bit. So I'm just going to take another drink here. Again, if this is all like flying by, feel free to ask a question or slow me down. We do have time today. Okay. So quickly, before we look at the app itself, what's going on behind the scenes? Well, I've got a 3-node Vault cluster running in Ubuntu VMs and an all-in-one Splunk instance, Splunk Enterprise instance in a 4th Ubuntu VM, all managed by multipass. Vault is running with an integrated storage stroke Raft backend, and it's actually the open source software, the OSS version of Vault. As I said, the Vault Enterprise license is required before you can, your Splunk base account is actually allowed to download the app, but all the actual data from Vault that the app expects, that's available in the open source version as well. Just to make that distinction clear. So it's the leader of the Vault cluster that will be writing the operational data to a file audit device in this case at any moment in time. And then we've got a Fluentd process that will be picking this up and passing it to the Splunk HTTP event collector, shortened to HEC. And that's all authenticated with a token. And then similarly, each of the Vault nodes will be generating telemetry, both specific to Vault via statsd and on a system level, which will all be picked up by a telegraph process running on each of those nodes and then passed back to that same Splunk hex, but with a different token to secure it for that purpose. So the operational data ends up in an events index in Splunk, and both sources of telemetry end up in a metrics index, all ready for the app to query, Splunk app to query. Okay, so and let's actually take a look at that Splunk app now. Again, for those just joined, please feel free to pose questions as they come to you. Let's keep this informal. Okay, so before we actually look at the app in action, I thought I'd give you a flavor for some of the insights it can provide. These screen caps are they more closely resemble an actual production environment versus my kind of vanilla demo setup. So I thought it'd be easier to talk to those. So we talked about namespaces earlier. Here you can see the default root namespace in green up top, with a second namespace NS1 in blue, giving you a quick sanity check on the recent token counts. And then below that, a few different breakdowns on those numbers by auth method and by time to live. Also note, you can quickly see what policies are being applied to the lion's share of them, including the always alarming root policy shown in red. Houston, we may have a problem. Sorry, I'm going between screens here. Here again, another sanity check on the deployment, showing you what's keeping Vault busy. Note that most of the operations shown in this example are reads and lists, highlighting the utility of performance replicas or read replicas, as I was talking about earlier. Again, those requests could be serviced by a secondary cluster, taking the load off your primary. And here we have a view on a specific secrets engine, the key value or KV secrets engine, and usage broken down by mount point. And then on the right, we're looking at leases by secrets engine, the AWS secrets engine, judging by those mount points. And so a spike over here might suggest that some category of credentials are persisting longer than needed, something to be investigated, certainly. Is a quick glance at the health of your deployment, both in terms of capacity and security posture, basically. And keeping with that sort of quick assessment theme, here we have an example of errors by path. So this would be a case, or this could be a case of teething problems with a new service, where lease renewals are failing for some reason, or it could be an early warning of some sort of denial of service attempt. The point is that you have these visual mechanisms, as well as the typical Splunk automation around alerting to kick off these investigations. And finally, as you'd expect, there's the usual sort of host-related telemetry that you find with any observability solution. But this has been tailored to critical metrics for Vault deployments. It may be, for example, that you've signed service level agreements with clients of your Vault, and so you'll need to maintain certain average maximum latencies on service requests, things like that. There'll be certain performance targets you have to hit, and this will help you see how close you are to satisfying those, to running into problems. And even in the case of an internal deployment, you want to make sure that it's scaling well and able to deal with spikes in service requests. If you're seeing persistent problems in this area, it may indicate that your architecture is no longer fit for purpose. Just jump onto the final bit about us. We're here to help if if you need some suggestions on that. Okay, so enough talking about it. Let's have a look at it. Note, as I said, this app is only available to Vault Enterprise customers. I just want to make that really clear. Splunk base. The link's there. At that link, there's a YouTube video as well. It demonstrates the app. It's about 10 minutes long, and it's got a much richer data set. And so it's actually where I got the screen grabs we just looked at. But for my data set, for those who are curious, I just used the HashiCorp has some benchmarking scripts in their Vault Guides. Vault Guides is a massive repo, but one of the things in there is benchmarking stuff, and I just generated a frankly pretty monolithic data set, but you get the idea anyway.
Okay, so all of my VMs are stopped at the moment, so I'm going to start bringing them up one by one and just show you how I do that. Okay, so I have Splunk up now on a VM. You can see that's on .9, and I can connect to it. Here's my Splunk instance. So now I'll just bring up my Vault VMs, and we'll see how healthy that cluster is. Okay, so all three of my nodes are now up, and I've unsealed one of them. So I'm just going to continue with that. And we should have a running cluster in a few minutes. Okay, so all three nodes, vaults are unsealed, and everything has come together on the cluster with Vault 0 as the leader for the moment. So all of the writes and whatnot are going to be to the log, are going to be coming from this node. And we see already 1 minute ago the audit log was being written to. So now if we bring up Splunk, or sorry, it's already up. Log into Splunk. I've already installed the app. Here's the summary that you'll land on when you bring up the app. It's showing all the vaults unsealed. Now you'll notice it defaults to the last 7 days. You can change that as you would expect in any other Splunk app with the time ranges. You can also filter based on cluster or based on your storage type. This, as we've said, is based on Raft integrated storage. So over the last 7 days, I haven't done a lot with this instance, but if we go back 30 days, we should see a bit more data. So again, I mentioned this in the presentation. This is fairly vanilla data, but you do have a link to HashiCorp's own walkthrough of this app, and that will give you a lot more. It'll give you a richer view of the app. So digging into one of the dashboards here, I've already bumped the time span up a little bit to 30 days. And it's much like, again, like you would expect with any Splunk app. Let's zoom into a critical point that we're interested in learning more about. So there we can see a little bit about what's happening on each of our nodes. During that time frame. Including some election stats. And the leader was switching quite a bit, so we might want to investigate that a little more. Again, memory usage by node. And you can, of course, expand these to look for more detail. Switching to reports now, if we look at one errors by time, you see a spike here on unsupported path. So if we wanted to investigate that a little more, this is Splunk running behind the scenes, so you can do everything that you would expect there. And if we dive into one of these JSON results, you can see this is basically what it looks like in the Vault Audit log. And we can see from the request that this unsupported path was to do with role governing policies. So that might be a place to start our investigation if we've implemented those or not, and go from there. Okay, so I hope that's giving you a little flavor for what you can see at a glance with this Vault app for Splunk. You notice now, like this demo's been running for a few minutes, so I just cut it down to 15 minutes. Thank you for your time and attention. I'll just finish up a few slides and answer any questions you might have.
Just to finish up, a little bit about us. So we're CHIP certified. That's certified HashiCorp implementation partners in both Terraform and Vault, and we got the public certifications as well. So we're here to help, basically. We're frontline support as well. And if we haven't seen the problem, HashiCorp will definitely be interested to hear from us. And so you'll get a quicker turnaround through us because of that. I mean, you're taking advantage of the complimentary workshops right now. And we're more than a HashiCorp partner, more than a Splunk Elite partner. We, excuse me, we're really about best in breed. So it's our market leading portfolio of data, operational efficiency, and security products has been curated with experience and care. It's it's a lock and key, and it's about meeting you at whatever stage you are in your cloud adoption journey. So, and we invest in our staff very heavily, so they're well trained, certified in all the technologies. And they're going to provide pre-sales, implementation, post-sale support. So it's about understanding a business solution and then looking at the right technology, right solution, which we've done for a variety of organizations across the UK, variety of sectors. So that's pretty much it. I hope that was useful. Thank you very much for your time and your attention. If you do have any questions, feel free to pose them now. Otherwise, take down that email address, and I'll be happy to respond in later time if something comes to you. But yeah, if if that's okay, then I'll just say take care and stay safe.